A very warm welcome to you all. Okay, and today in this video we are going to learn about the fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? So before going into the fundamental theorem of arithmetic, we will know something about the prime numbers and composite numbers. Prime numbers and composite numbers. So what are prime numbers and what are composite numbers? The first one is prime number. Prime number. What is prime number? Prime number is the number which have only two factors. Which have only two factors. Only two factors. Okay? What's a number? That numbers which have only two factors are called as prime number. Example. What will be the two factors? The number itself. The number itself and 1. Okay? The number which have only two factors, the number itself and 1 is called as prime number. Example 2, 3, 5, 7, 11. These all are prime numbers, and so on and so on. These all are prime numbers. So 2 has only two factors, 1 and 2, because factors means the number which can divide this number. Okay, so 2 is the number which have only two factors, means 1 divide 2, 2 divides 2. No other numbers can divide 2. In the same manner, 3 has two factors, 1 and 3. 1 can divide 3, 3 can divide 3, no other number can divide 3. In the same manner, 5 has two factors, 1 and 5 itself. 1 can divide 5, 5 can divide 5, but no numbers other than these two numbers can divide 5. That's why these are the numbers which has only two factors, 1 and itself. That's why 2, 3, 5, 7 and 11 are the prime numbers. Okay, so this is the prime numbers. Next to it we have composite numbers. Composite numbers. So what are composite numbers? Composite numbers means the number which has more than two factors. The number which has more than two factors are called as composite numbers. Example we have 4, 6, 9, 10, 8 and so on. These are the numbers which have only two factors, which has more than two factors, right? And we can say in other words that the number which are not prime, are called composite, except one. One is neither prime nor composite because it has only one factor. And that factor is 1. So the number which has only two factors, the number itself and 1 is called prime numbers. Example 2, 3, 5, 7 and 11 and so on. And the number which has more than two factors, are called composite number. Just like 4 has factors 1, 2 and 4. It has three factors, means there are three numbers which can divide 4. 1 can divide 4, 2 can divide 4, 4 can divide 4. In the same manner, 1 can divide 6, 2 can divide 6, 3 can divide 6 and 6 can divide 6. So these are the numbers which have more than two factors. That's why these numbers are called composite number. So I think till now you have understood that what is prime number and what is composite number. So next to it we have factors of a number. How we can find the factors of a number? How we can find the factors of a number? How we can find the factors of a number? So, 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 so we have example 24, and you have to find what are the factors which can divide 24. या फिर the question will be write all the factors, write all the factors which can divide 24. So what are the factors we can divide 24? So we have 2 to 3 methods through which we can find what are the factors of 24. Okay, so the number which can divide 24. Okay, so if you have to write the factors of 24, just do like this one, prime factorization. What will you do? Prime factorization. Prime factorization. What is prime factorization? Means we will divide this 24 again and again by prime factors till it is completely divided. Okay, so if you divide this number 24 by 2, you will get 12 as quotient, and if you divide this by 2, you will get 6 as quotient. If you divide this 6 by 2, you will get 3 as quotient, and if you divide this number by 3, you will get 1 as quotient. Right? So unless you get 1 here, we will not stop. Okay, so these are the numbers which can divide 24, and if you have to write the factors of 24, then what will you write? To write the factors 24, the first one is 2. The first one is 1. 1 can divide 24. But this is not a prime number. And if you have to write the prime factorization of this number, so what will you write is, 1 will not be there. 1 will not be there. So I am not writing prime factorization. I am just writing the factors of 24. So 1 is also the factor of 24 because 1 can divide any number. 1 can divide any number. That's why 1 can divide 24. And the same manner, 2 can also divide 24, 3 can, whichever number is appearing here is the factor of 24. So firstly, 2 is the factor of 24, 1 is the factor of 24, here 3 is also the factor of 24, 6 is the factor of 24, 12 is the factor of 24, 24 is the factor of 24. Is there any other number which are the factor of 24? Yes. What is that number? This one. 2 to the 4. 4 is also the factor of 24. 2 to the 4, 2 the 8. 8 is also the factor of 24. So these are the numbers which are the factors of 24. That is, these numbers can divide 24. That's why these numbers are called factors of 24. I hope you have understood till now. Okay, so these are the numbers which are the factors of 24. But if I'll ask you that what are the prime factors of 24? What are the prime factors of 24? If I'll ask you from you that what are the prime factors of 24, so you will identify what are the numbers which are prime here and which are dividing 24. So 2 is prime number which is dividing 24. So 2 is the prime factor of 24. In the same manner, 3 is also dividing 24. That's why 3 is the prime factor of 24 because 3 is also a prime number. No other number which are prime as well as factor of 24. That's why 2 and 3 are the only prime factors of 24. Okay, so these are the numbers which are the factors of 24. So in this manner, you can write the factors of any number or the prime factors of any number. I hope you have understood till here. Okay, so after this, if you have to write the factor, this is the prime factorization method. This is the prime factorization method through which you can write the factors of any number. One other method through which you can write the factors of any number. There is one another method through which you can write the factors of a number. What is that method? And that method is tree method. Tree method. Before moving to this topic, fundamental theorem arithmetic, I am just dealing with some basic concept which will help you in understanding the fundamental theorem of arithmetic. Okay, so tree method. Like I am taking the same example 24. Okay, so you just identify which number can divide 24. The first one is 2. So in how many times 2 will divide 24? That is 12. Again, you have to factorize this. How? Which number you will select which will divide 12? 2 is the number which can divide 12 in how many times? In 6 times. Okay? 2 is again the number which can divide 6 in 3 times. So, whatever number is appearing this side are the prime factors of 24. Right? So a question arises here is 12 or 6 not a factor of 24? So this is not the case. 12 is also the factor of 24. 6 is also the factor of 24. 2 to the 4 is also the factor of 24. 2 to the 4 to the 8 is also the factor of 24. Right? So in this manner you can write all the factors of 24. Right? So here whatever number is appearing in the left side are the prime factors of 24. If you will write what are the prime factors of 24, so the answer will be 2 and 3. So 2 and 3 is here the prime factors of 24. But if I'll ask you write all the factors of 24, write all the factors of 24. So what will you write? You will write 2, 1, 3, 4, 6, 8, 12 and 24. These all are the numbers which can divide 24. That's why these all are the numbers are called the factors of 24. So this is a tree method through which you can find the factors as well as prime factors of the any number. I hope you have understood till here. Okay? So next to it we have come across the topic that is fundamental theorem of arithmetic. So what does this theorem say? What do this theorem say, or what does this theorem say? So according to this theorem, any number or any composite number can be written as the product of prime number or the power of or the product of power of prime number. What does this mean? I am writing a statement. So look at here. Any number can be written as product of prime number or the product of power of prime number. Okay, any number which is positive. Okay, so any positive number except one. So we can specifically say here that any composite number any composite number. Any composite number can be written as the product of prime number or the product of power of prime number. So what does this say? I'm taking the same example again, 24. 24. So do the prime factorization here. 2 will give 24 in 12 times. Again, 2 will give 12 in 6 times. 2 will give 6 in 3 times. And 3 will give 3 in 1 times. So what is the prime factorization of 24? The prime factorization of 24 is 2 into 2 into 2 into 3. So this is the required prime factorization of the 24. So you can see here, this 24 is written as the product of prime number. This is also prime number, this is also prime number, this is also prime number, and this is also prime number. So 24 is written as the product of prime number, and this can also be written as this, like this. This can also be written like this. How many 2 came? How many times 2 came? 3 times. So you can write here 2 into 2 into 2. It means 2 to the power 3. Right? So 2 to the power 3 into 3. So you can see here that 24 can be written as the product of the power of prime number. Here 3 to the power, we have 3 to the power 1, and here we have 2 to the power 3. So from this example, you can understand or see that 24 can be written as the product of prime number or the product of power of prime number. Okay, so this is the fundamental theorem of arithmetic, that any composite number can be written as the product of prime number or the product of the power of prime number. Okay, so this is the concept here. You can understand from it. You can understand from it. So I take one more example through which you will be clear that what does this theorem specify or what does this theorem say. Okay, so look at, I have erased the definitions as well, so don't bother about it. I'm going to make you understand everything. So the question here is, we have written 36. We have taken a number 36. So do the prime factorization of this number. So 2 in 18 times will give 36. 2 in 9 times will get 18. 3 in 3 times will get 9, will give 9, and 3 in 1 time will get 3. So 36, the prime factorization of 36 is 2 into 2 into 3 into 3. Right? This is the prime factorization of 36. So it can also be written as 2 to the power 2 into 3 to the power 2. So you can see here that 36 is a composite number, and it can be written as the product of prime number. Here 2, 2, 3, 3 are prime numbers, right? So 36 can be written as the product of prime number or the product of the power of the prime number. Means you have taken 2 to the power 2 into 3 to the power 2. So any composite number can be written as the product of prime number or the product of power of the prime number. So this is the theorem that it says. Okay, so this is the fundamental theorem of arithmetic. So I think you have understood everything till here. Okay, you have understood everything till here about the fundamental theorem of arithmetic. So I'll say one more thing in it. Firstly, the thing is number of distinct prime number. Number of distinct prime number in the factor of in the prime factorization prime factorization of any composite number. Look at it. You will have to find a number of distinct prime number or number of factors both. So how can you find the number of distinct prime numbers in the prime factorization of any composite number, or how you can find the total number of factors of any number? Okay, so to find the total number of factors, so you have taken the prime factors of 24 as 2 into 2 into 2 into 3. So you can see here what are the numbers of distinct prime numbers 1 and 2. So if you will take this one, number of distinct prime number, you will get 2. And if you have to find the number of total number of factors of 24, so what will you do is you can write this like this one, 2 to the power 3 into 3 to the power 1. So to find the total number of factors, what will you do is this 3 one, right? So 3 plus 1, and here 1 is here, so 1 plus 1, and multiply this one. Means you have to, if you have to find the total number of factors of any number, so what will you do is, firstly you will do the prime factorization of that number and write it as the product of power of the numbers, prime numbers. Thereafter, whatever is the power of the prime number, increase it by 1 of in every factors, whatever is the power, increase it by 1 and take the product. So here we have 4 into 2, so total number of factors of 24 is 8. Total number of factors of 24 is 8, and if you ask about what is the number of distinct prime factors, is only 2. What is that? 2 and 3. 2 and 3. So you can visualize it by this. So 24, if you write the factor 24, you will see 1 is the factor, 2 is the factor, 3 is the factor, 4 is the factor, 6 is the factor, 8 is the factor, 12 is the factor, 24 is the factor. So how many factors of 24 are there? 4 to 6 and to 8. And what we found here is 8. So in this manner, you can also find the number of distinct prime factors and the total number of factors of any number. Okay, so this is all about the fundamental theorem of arithmetic, in which we have studied about the prime numbers, composite numbers, and the prime factorization of a number. Then after at the end we have to study about the fundamental theorem of arithmetic, in which we have studied that any composite number can be represented or expressed as the power of prime factor, as the product of power of prime factors, or as a product of prime numbers. Then after we have studied about how you can find the number of distinct prime numbers. So you can find this like that. Find the number of distinct prime like this one, and if you have to find the total number of factors of a number, you can find like this one. Okay, so I think you all have understood till here. Thank you for watching. Keep watching.